Okay, we're gonna go ahead and start this. Thanks for your patience, everybody. This was a challenge, as you can see. I'm Charlie Nielsen, president of the club. Probably you all know that. So we have some other officers in the room and maybe on Zoom. We may get some reports from them later. But as tradition would have it, we always have our guest speaker first. And if anybody was really just here for that, didn't want to stick around for the business meeting, we may let you escape in between. So and I'm very pleased that we have a return of Professor Rudi Lindner. Many of you tonight have probably seen Rudi before because he's spoken to us a number of times through our club history. He's a professor emeritus, not only history, but astronomy at the U of M. And so if you have any questions about astronomy or history, and particularly history of the U of M astronomy, this is your guy. Dr. Lindner earned his PhD from the University of California, Berkeley in 1976. His main fields of study are medieval world, the Ottoman Empire, about which he has authored a book, and one of our favorite topics, astrophysics. Rudi has talked to us previously about a wide range of topics, from why astronomers go crazy at a South Africa observatory to the history of UFOs as examples. Rudi is an excellent speaker, but when I alluded to that in an email years ago, he responded by saying that some people refer to him as the ham that smokes itself. There was one more thing that makes tonight special. It's Rudi's birthday.
What's really terrible about being the ham that smokes itself is, of course, that I'm Jewish.
Anyway. Anyway, I took a look at some records and I found out that Rudi last spoke to us in 2022. And before that was also July 17th in 2015. So that was his birthday as well. So we had her for his birthday twice now. So with that, how about happy birthday, Rudi? Happy birthday. All right, take it away. Please. Okay.
Let me take advantage of conditions of maturity and sit down. It has been said of me and of my work that it is all smoke and mirrors. Well, you saw the smoke when you came here this evening. Let's see whether you'll see the rest. I don't have anything earth-shaking to tell you this evening. But what I'm going to do is fundamentally tell you a story for which there really is no moral. But it's one of those interesting sidelights come to you when you spend some time looking at the history of astronomy or astrophysics in the 20th century. There is a Michigan connection, not a big one, but there is a Michigan connection, which we'll see soon enough. Speaking of something called the Campbell-Kapteyn effect, sounds like it's very technical. And the fact that I have some understanding of it is a demonstration that it is not technical at all. So without any further ado, let me talk about some of the people involved. The first is Wallace Campbell, who was a native of Ohio, but went to the University of Michigan and ended as the president of the University of California, probably the longest serving president of the University of California. Here he is wearing his academic costume, which is rather peculiar because the academic garb of the University of California is, of course, blue and gold. So the red garb is an indication that he is a graduate of Stanford. If you have anything to do with Cal, you know that Stanford is You're not supposed to have anything to do with it. And as a Cal graduate, I will tell you that there are hundreds of junior colleges in the United States. We have one a couple of miles from here. But there is only one junior university, Leland Stanford Junior University. And you can use your imagination to take you further with that. You go to Stanford, you can go to their museum where you can actually see Leland Stanford Jr.'s last breakfast, which will also tell you something about the macabre that exists in Palo Alto, California. But enough of that. Campbell's professional career was spent at the Lick Observatory of the University of California, located 18 miles directly east of San Jose, California, on Mount Hamilton. It was the first of the great mountain observatories, and it still has superb seeing, superb atmospheric conditions because it gets a nice laminar flow from the Pacific Ocean and doesn't get the air doesn't get disturbed as it does in most other parts of the United States. Jacobus Kapteyn, much older man than Campbell, a Dutch astronomer, although he spent a little bit of time consulting with institutions in the United States. This is the Astronomical Institute of the University of Groningen in the Netherlands. Notice anything peculiar about it?
No telescope.
Pardon me?
No telescope.
No dome, no telescope. Kapteyn was an astronomer who worked with statistics. He worked with observations that were obtained and photographs from other institutions, especially in Africa. And he is the pioneer of what we would call statistical astronomy. The third person involved is Benjamin Boss. His father was also an astronomer. The Boss father and son worked at the Dudley Observatory in Albany, New York. And their specialty was such things as the precise identification of stellar positions and how those positions changed over time as seen against the background of the sky, what we call proper motion. And Boss was a later discoverer of what we call the Campbell-Kapteyn effect, but you could, with justification, call it the Campbell-Kapteyn-Boss effect. Well, here is Wallace Campbell as a young man. I'm going to look at his career. Took a degree in civil engineering at the University of Michigan in the year 1886. At that point, and for some decades later, if you took a degree in engineering at the University of Michigan, you also had to take a year of astronomy. So the astronomy department benefited greatly from this peculiar requirement of the engineering school. Campbell got his degree, went and taught briefly at the University of Colorado, but ultimately came back to Michigan. Had seen, just casually, a book on astronomy for popular audiences written by Simon Newcomb, who was the great mathematical astronomer in the United States of his generation in the 19th century. Campbell was so affected by this book that he picked up that he read it in a day and a half and then decided that what he really wanted to do was to become an instructor. He had been teaching mathematics at Colorado, told the people at Michigan he wanted to come back and work at the observatory here, the Detroit Observatory. They said, well, that's fine. We can only give you about $900 a year. And he was making, I think he was offered $3,000 at Colorado. It's a substantial salary for those days. But he elected to come back to the University of Michigan. After the Lick Observatory opened, they had two remarkable instruments, the second largest refracting telescope in the world, a smaller 12-inch refracting telescope, and shortly thereafter, a 36-inch reflecting telescope. And they needed to staff it. And at that point, and for many years thereafter, the great degree granting institution in astronomy was the University of Michigan.
Flight of stairs I see coming out of that front door.
Yeah, that's the front
Oh,
door of
man.
yes, that was the dormitory
Okay.
where the astronomers.
Oh, yeah, I see it's in front
Where
of
the
me.
astronomers lived. Then on the left side of the picture is the wondering schoolhouse that served their children.
Do you know if the 36 inch is still the same one that's there, or has it been?
Yes, no, it's the lens has been slightly refigured.
But the 36
36
inch
The
reflector.
36-inch reflector, the Crossley telescope, is still there.
I think I've looked through that.
Yeah, it has a terrible mounting, and when I first saw it as a school student, the astronomer in charge, Nicholas Mayall, went out of his way to tell us that he had used that telescope and hated it, and he kicked it. It has a very peculiar mounting.
I don't remember. It's before
It
I was
looks like-
into astronomy.
Yeah, it still has the original mounting, but there's an observing platform, so you don't see much of the original mounting. The original mounting looks like, cement mixers? It looks like the truncated cone, two truncated cones of two cement mixers.
Nice.
It was suggested that when Charles Dillon Perrine designed that mounting, that he had some sort of fantasy of two cement mixers having sex. 19th century astronomers' jokes. And here is an early illustration of the 36-inch refractor. It's a marvelous instrument. I mean, think of the pleasure you have. Look at the eye end of that telescope. Look at all of the doodads. Also, the donor, James Lick, is buried in the mounting of the telescope. The director came to him and said, are you sure you want to do this? Are you sure you would like, you could be cremated and we could put an urn there. And Lick said, no, I intend to rot like a gentleman. Lick's other great benefaction is that he made possible the creation of the Ghirardelli Chocolate Corporation. So, anytime that you choose to have Ghirardelli chocolates, know that this you're paying homage to the creator of the Lick Observatory.
Excellent.
Edward Holden was the first director of the Lick Observatory. He was an administrator first, not an astronomer, but he decided that what this telescope should really be used for was for spectroscopy, which was then becoming a major field of interest in astronomy. Holden knew nothing about spectroscopy, but he went out of his way to hire some people who did work at it. And when Campbell came, Holden said to Campbell, look, you work with one of our spectroscopists, and he'll teach you how to work this. And then what I want you to do is I want you to use the spectroscope to determine the velocities of the stars either coming toward us or going away from us. You can determine proper motion by taking a photograph 1 year and waiting 5 years to take another photograph and seeing if the star changes against the background. But that doesn't tell us about another component of its velocity, and this is what you're going to do. And Campbell was very lucky because the man who was the master of spectroscopy in astronomy at that time was James Keeler, been trained in spectroscopy at Johns Hopkins, which was the home of spectroscopy used in chemistry at the time. And Keeler schooled Campbell in the use of the spectroscope. Keeler became, in fact, director of the Lick Observatory, and Campbell was afraid that Keeler was going to take over his work. He says, "No, I'll work with the Crossley telescope. Thank you. You continue your work with the big refractor and taking spectrographs, using it spectroscopically." So here's a photograph of Campbell at the eye end of the 36-inch refractor with the spectroscope that was in use at the time. Here it is. It was an optical spectroscope, so the light comes through the eye end of the telescope, and then it passes through a collimator, then hits a prism, and is refracted. And you look through the eyepiece that's set at an angle, and you will see a spectrum. And even with a 36-inch telescope, that image of the star has been smeared over a length, and so therefore the image is going to be fairly faint. And you want to be able to measure the wavelengths of what you've got, so you have to have a comparison spectrum, which comes from a spark apparatus that's on the floor next to you. It's all very messy. And visually obtained measurements work very good. Well, Campbell was a very shrewd man, and he went around to see if he could find a benefactor. Luckily, at that time, there were a number of people in San Francisco who had made great fortunes during the gold rush. One of them was Darius Ogden Mills. Mills was interested in the University of California. He built one of the very few buildings in San Francisco that survived the 1906 earthquake. He made a fortune in railroads and buildings, and he agreed to pay for a photographic spectroscope known as the Mills spectrograph. It's still in use today. Carefully designed by Campbell. You see it here without the apparatus that keeps the temperature constant. The Mills spectrograph turned out to give excellent images, excellent spectra, and consistent values for the things that like wavelengths and the like. Just to remind you that the movement of the star can be analyzed into the tangential velocity, which is like the proper motion. And then there's the part that is the motion towards us or away from us, which can be measured, a Doppler shift, using the spectroscope. So here is a spectrum of the planet Saturn, with the slit of the spectroscope set across the ball of Saturn and across the rings. And what you see here is you see the spectrum of the planet and the spectrum of the rings. And you can see the spectrum of the planet is at a slight tilt, because as the planet rotates, some of it is going towards us, some of it is going away. So that part of the spectrum that's coming towards us, the spectral line is shifted to the blue. The part that's turning away is shifted toward the red, and that's why you have that. And something similar happens with the spectrum of the lines of the rings. So here is, if you take the spectrum of a star and you compare, for instance, spectrum against, say, the spectrum of the sun, you see the spectrum of the sun is in green, and what has happened is they've used a densitometer so you can measure the lines by the blackness of what you see on the plate. And so you'll see here that the red spectrum represents the spectrum of the star, and you can see here a slight shift towards the red, which is an indication of the velocity going away from us, the radial velocity of that star. Well, Campbell went at this with a vengeance. And after a while, he said, look, we can use these radial velocities to determine, for instance, from the way as the sun is going through space, it is approaching some stars and going away from other stars. So it's be like, when you're walking through a forest and the trees that you pass are moving away from you, the trees in back of you coming closer together. But in order to get a clearer picture, the observatory is a great place, but half of the sky is not visible from there. So Campbell went to Ogden Mills and said, we would like to set up an observatory in the Southern Hemisphere to continue this program that you've been so helpful with. And Ogden Mills said, sure, why not? But I don't have the money to build you a 36-inch refracting telescope. I mean, in dollars of the 1880s, that was $750,000. Well, $750,000 today, that's enough to buy you a calculus textbook. So they established a station at Santiago, Chile, on the San Cristobal Hill, which is in the center of this image. And here is the southern station, still exists, still in use, although not by the observatory. And inside, what they built was a replica of the Crossley telescope without the Crossley mounting, designed specifically to take spectrograms of southern stars using, here you see a version of the Mills spectrograph with its cooling apparatus. By the way, the Crossley telescope, and maybe there was something to be said for this business about cement mixers copulating. The Crossley telescope had children. What do you think the Crossley telescope's son was? 36-inch reflecting telescope, just like this. It's the reflecting telescope that used to be up at the Detroit Observatory.
Wow.
That was designed on the basis of the Crossley telescope.
Oh,
And which is one reason why it was falling apart and had to be demolished in 1974. And there are a number of other sort of cousins and grandchildren of the Crossley telescope. So with this, Campbell could go to town. But he wasn't about to go to Santiago. So the Lick Observatory, and by this time, James Keeler had died, and Campbell had become the director of the observatory. And Campbell arranged for Lick Observatory staff to go down and spend years in Santiago, taking spectrograms that they would send up. And here in the center of the picture, first of all, seated on the ground are sort of young lions of astronomy in 1914. And in the center seated is Heber Daust Curtis, University of Michigan, 1896 in the classics, who became an astronomer at Lick Observatory, and Campbell sent him to South America to take spectrograms. He is seated directly in front of Campbell, who was the host at this meeting of the American Astronomical Society. To Campbell's left is George Ellery Hale, director of Yerkes, Mount Wilson, etc. Now, there are any number of other astronomers in this photo. Look at the back row at the far left. The sixth person in the back on the far left, young man. Any of you, by any chance, recognize this man? Any idea? No. It's Harlow Shapley. Who later became Curtis's opponent in the great debate in 1920 about the nature of the spiral nebulae. Anyhow, it's just a minor point. Now, I'm going to make a scenic detour for a minute, because I have to talk a bit about stellar spectra in general. And it was recognized fairly early on in the 1830s and 1840s that if you took spectroscope and looked at the spectrum of this star and that star, they were not all the same. There were different groups of spectra. And the person who first did a classification was this gentleman, the Jesuit Angelo Secchi, who was the director of the observatory at the Vatican, and who in the right-hand stamp, you'll see an image of the very small spectroscope that he used. And Secchi, after a while, did a classification of the spectra into 4 types. The type number 1, it turned out, are stars which have lines of the element helium. They have relatively few lines, and these tend to be very bright stars. The second class are stars which have more lines, more elements, including hydrogen. Class 3 is like the spectrum of the sun. And class 4 are peculiar stars, reddish stars, that have not so much lines, but bands from molecules. Well, nobody understood what this meant, but there was a general feeling that it was a classification that somehow was related to temperature. That class 1 probably had the hottest stars, class 4, the stars with the coolest temperatures. I mean, in the low thousands. Well, Secchi classified maybe 60, 70 stars. The place where spectral classification became a factory was the Harvard College Observatory. Here, under the direction of Edward Pickering, who was director from 1880s until his death in 1918. he originally employed local people who had some kind of mathematical aptitude to study the photographic spectra that his telescopes were producing. But he found that their work wasn't very good. And he said, well, my housekeeper could do better work than that. So he hired her. And she became the head of a group of women who spent their days classifying stellar spectra. It will perhaps not surprise you to know that these people were known at the time as Pickering's harem. A number of them became very, very important in the study of stellar evolution. Perhaps the most famous, well, one of the most famous is Annie Cannon, the sage of Delaware, who spent her lifetime classifying stellar spectrum. She's looking at a plate that contains a number of spectra on it, maybe 100 or 200. And beneath that photographic plate is a mirror. And then there's a window that you can't see. And so the sunlight comes through the window, goes through the mirror, comes back and illuminates the photographic plate. And then she works from that. And she would simply say, star 23, the spectrum is type F3, and just do this for a secretary. It's marvelous. She classified probably 350,000 stars in her career. She is the first woman to have received an honorary degree from Oxford University. And so here is one view of the Harvard classification adopted by Pickering, and ultimately the classification that's used today. And again, it was seen, as we see now, as a classification in terms of temperature, but also in terms of color. And we'll get back to that in a bit. It's not very important, but I want you to be a little bit aware that during this time, you weren't simply you could use the spectra to obtain velocities, the radial velocities of stars. But the question was, how do we explain the differences in stellar spectra? What do they do to? Is it due to the fact that some stars have only helium and other stars have manganese? Is it that they were stars were constructed by God using James Beard's cookbook? or is there something else about them? This was a big problem because, first of all, the question was, do stars evolve? Interesting question. But that implied another question to which nobody had any idea. What is it that powers the stars? So here, just for comparison, there's Secchi's classification and then the Harvard classification, which ultimately it began as alphabetical, A, B, C, D, E, but people like Annie Cannon and others determined that the sequence really should go. They revised it: O, B, A, F, G, K, M, R, N, S, which when I was studying astronomy, you memorized by O, be a fine girl, kiss me right now. And the S either stood for smack in terms of being kissed, or smack in terms of she gives you a whack in the face. But there's also other ways of doing it, and one is at the bottom: O big and furious gorilla, kill my roommate next Saturday. That's one way of memorizing the sequence. Okay, so O, B stars tend to be blue. Why? F, G stars tend to be like the sun, Other stars tend to be reddish. What does this mean? Yes, there seems to be a color sequence, seems to be a temperature sequence, but does that say anything about age? What can we say about stellar evolution from a chart like this? And can we say anything if we don't know how energy is being produced in a star? One idea was, how do stars form? One idea was, well, we know that every day there are tens of thousands of meteors, that come into the Earth's atmosphere. And as they come into the Earth's atmosphere, they heat up. How many meteorites are coming into the sun? And so there was one theory that the sun is heated by the inflow of meteorites. This actually was fairly popular for a time. Again, what other heating? If the sun, for instance, consisted entirely of charcoal briquettes for a barbecue, that doesn't heat it for very long. So there are questions about this. So one of the theories is of a temperature arch. You have the beginning of the star, meteorites come in, it heats up, it achieves a maximum heat, and then it slowly cools off. So at the top of the arch, it's sort of bluish, blue-white, and on the right-hand side, it becomes red.
And
That was one theory.
And it's picked up a lot of carbon from all the stuff coming into it.
Now, what Campbell discovered when he looked at all of the spectra that he had and looked at the radial velocities based on a large number of spectrograms was that the white, bluish white stars had velocities in space that were relatively slow. But as you went down in the direction of the reddish stars, the velocities got greater and greater and greater. This is effectively the Campbell-Kapteyn effect. What does it mean? What causes this? Get back to that. Here is Kapteyn visiting Mount Wilson Observatory in California, having a picnic with his wife. How many of you dress for a picnic that way? Not many, I should think. About the same time as Campbell, Kapteyn looking over the enormous body of material that he had developed over the years. For instance, he had a plan of selected areas in which observatories would look at a particular area of the sky, send the photographs, and he and his workers would make tables of the spectral type, the magnitude, velocities, etc. So Kapteyn, about the same time as Campbell, came up with the same notion that as stars evolve along the spectral sequence, that they got faster. Substantially faster. Why? I have no idea. Benjamin Boss, working solely from data involving proper motions, came up with the same result. Kapteyn, Campbell, Boss began to wonder, what's going on here? And others came to wonder too, because this was a sensational discovery. completely unexpected. So, just to show what the proper motion means. Again, Boss comes up with the same idea. His father had begun the program at Dudley Observatory. Well, at about this time, people began thinking again seriously about stellar evolution. And in 1914, Henry Norris Russell of Princeton published this diagram, which is the first of what we know as the Hertzsprung-Russell diagram, which is a fundamental diagram in stellar astronomy. And what Russell found was that, first of all, this diagonal thing is a main sequence. In other words, spectral type is on the x-axis, magnitude of the star is on the y-axis. So the main sequence goes from some very hot OB stars down to some very faint and cool red stars. But Russell also found these oddities at the top, very luminous stars that also were very red. Believed they were very luminous and red, which means they had low temperatures. They had to be very large. They had to be giants. One of the nice things that occurs when you teach astronomy or history of astronomy is, you'll talk to the students at some point about the Hertzsprung-Russell diagram, because Hertzsprung found a similar diagram, devised a very similar diagram about the same time. As you ask students to explain the Hertzsprung-Russell diagram, and they say, well, it's a diagram that plots Hertzsprung against Russell. These were the same students who would also always, in the middle of some exam, remark about, Edwin Hubble, that famous astrologer. I mean, this indicates how much of a failure I was as a teacher. So people began thinking, well, what does this diagram tell us about stellar evolution? And Russell developed a theory known as the giant dwarf theory, which is that huge masses of gas become sort of giant spheres. They won't be very hot, but they will begin to contract under gravity. And the pressure of gravity will heat them up. So they will go from the upper right to the upper left. And then when they've achieved maximum temperature, they will slowly begin to cool down. So from giant to dwarf. And that became the accepted theory of stellar evolution for about a decade or so and a half. Okay. But that didn't explain this strange effect. Who was Boss? Benjamin Boss. Maybe what we're talking about here is the stars are getting faster as their color changes, or as they get older, as they move down the main sequence. Maybe gravitation is not at work here. Kapteyn, who was nobody's fool. Maybe, when we have these O and B stars have these very low velocities. Maybe when stars are very young, gravity doesn't mean anything. And Campbell, does gravitation become effective only after evolution has set in? Now, this is crazy. And they knew it was crazy. But they couldn't think of any other explanation. Why should a star's color have anything to do with its velocity? Why should its age have anything to do with velocity? People said, well, maybe as stars get older, they meet more stars along the way, and they get jostled around a bit, and so their velocity increases. A nice theory, but it turned out that it doesn't work out. That there aren't enough meetings of stars, so to speak, to produce this change in velocity. The great Oxford astronomer Herbert Hall Turner, who had a monthly column in a British astronomical journal, stated around 1920 that the Campbell-Kapteyn effect is the great mystery of the stars, and it really deserves close attention. It is the most unexpected and spectacular thing that we know about the stars. And so they swept it under the rug. They couldn't explain it. And so it disappears from the literature. You look at a textbook from 1927, Henry Norris Russell's textbook. Not a word. Not a word. You look at popular books. Not a word. Standard book on the Milky Way, published in 1941 by Bart Bach and his wife Priscilla Bach, book that stayed in print. Well, it's still in print. It's in its fifth edition. Doesn't mention it at all. Should. Talks about the kinematics of the Milky Way, but no, not there. It disappears. I suspect that this happens in science more frequently than one might think. But it is dazzling when for about 10 years or so, everybody's fascinated by this and wants to explain it, and then it just disappears. Clues were there, but nobody put them together. Here is a photograph of members of the American Astronomical Society meeting on an island in Lake Erie in 1910, 1911, something like that. And on the front row, the second from the right in the front row is Frederick Sears. He's just in front of the astronomer Barnard. And Sears worked at Mount Wilson Observatory, and Sears was interested in the colors of stars. And Sears made an interesting observation, just a casual observation in one of his articles, that if you look at the Great Nebula in Andromeda, that the bulge at the center is of a different color than the spiral arms. Spiral arms tend to run bluish, and the central bulge tends to be reddish. Casual observation. Later, at Mount Wilson, there was probably the second greatest observational astronomer of the 20th century, Walter Baade, who got interested in these matters. Here he is. He is actually here at a conference, summer conference at the University of Michigan in 1950. Took advantage of being in Michigan to buy a new car, drove the Mount Wilson astronomers back to Mount Wilson with him. He didn't have a license. He had no training in driving. In the car were such future luminaries as Alan Sandage. Sandage wrote about it. We expected to die every day because he thought that the line in the center of the highway was the guide that he should use to drive. There you go. Baade was able to show that, in fact, In a spiral nebula, in a galaxy, the reason for the difference in color between the central bulge and the spiral arms is because, to be very simple, as he put it, there are two different stellar populations involved. There is a population of younger stars that tend to be bluish, population 1, and population 2, much older stars that you find in the bulge and in a halo around the galaxy. So population 1 consists of relatively young stars, which tend to go in circular orbits around the center of the galaxy. These orbits are uniform, and they tend to involve the stars in relatively slow velocities. On the other hand, population 2 contains stars that are in the center, in the bulge, and especially in the halo. Stars in the halo, if you are in one of the spiral arms and stars in the halo are coming past you, they're really zipping past you. They will have higher velocities. So this is, Bada had no intention to care less about the Campbell-Kapteyn effect, but he had found one line of argument that casually explained this, that the older stars, which tended to be yellow-red, would have higher velocities than the stars that had been formed in the spiral arms. A little bit later, there were two astronomers at Princeton who had succeeded Henry Russell. One was Martin Schwarzschild, seen here with his wife Barbara. The second was Lyman Spitzer, known as a mountain climber as well as an astronomer. Spitzer was the man who, more than any other astronomer, is responsible for the building of the Hubble Space Telescope. Already in the 1940s, he was interested in building a space telescope. Spitzer was interested in the question of how are stars formed? What are the circumstances in which a star is created? Gravitation from, whatever, out of a clump of gas. Martin Schwarzschild was interested in the structure and evolution of the stars in general. And his great fame is that he said, look, if you really want to understand things like stellar evolution, we should use computers. These adding machines don't work, or they work too slowly. And in 1951, Schwarzschild and Spitzer wrote a landmark article in which they said, look, if we want to understand the formation of stars, we want to look at what are the things out of which they form, to be really looking at what happens in giant interstellar clouds, such as these, which you probably know as they're called the pillars of creation in popular magazines. And the stars would be born as small globules in these large molecular clouds. And these molecular clouds have masses that are thousands of times greater than the mass of a given star. Therefore, it is these clouds that have a great impact on what the velocity of stars are as they pass near these great interstellar clouds. And Spitzer and Schwarzschild mathematically were able to demonstrate the effect of these large interstellar clouds on speeding up stars, in fact, creating another reason for creation of the Campbell-Kapteyn effect. Well, here's another great interstellar cloud, the Horsehead Nebula. Now, you're kind enough to send me emails from the Lowbrows. This image is from a C-star 50.
I don't think so.
I find that deeply impressive. I mean, this is a very small lens. And yet it's providing all of this. It's fascinating. I'm sorely tempted to buy one. First of all, because of what you can do with it. Second, it is so small that I can hide it from my wife. Oh, this is going out over Zoom. Ouch for you.
My wife bought me one, maybe your wife will.
There's a good idea.
You can take a hint, maybe.
Positive. Oh dear. What is it they say in Alice in Wonderland? A very merry unbirthday.
No, it's what the DoorDash do.
And here's another example, which is a photograph that I'm sure you've all seen of one of Barnard's dark nebula. So these play a decisive role as well in the creation of this interesting the Campbell-Kapteyn effect, which it turns out is a footnote. This thing which in 1915 was, you know, front page picture in the National Enquirer. National Enquirer mean anything to your generation? You know, People magazine maybe more to you. And now it was just sort of a footnote. And now we finally understand it. Where am I here? I apologize, I've gone on far too long. Yes.
We don't mind it.
That's very kind of you. You need therapy.
That's good.
Not gonna deny it.
And from 2002 until 2020, not only the Hubble telescope, this is the Spitzer space telescope, which was designed specifically for the study of infrared objects and for the study of these giant interstellar clouds. Well, I've told you a story this evening, story of the rise and fall of an astronomical fact. It involves some interesting personalities. It's tangentially involved with big issues such as stellar evolution. But students used to say to me, what does this mean? Does this have anything to do with my life? Well, this evening I'm prepared to prove to you that the answer is yes. I have one last photo to show you of the influence of interstellar molecular material on a population.
Sure.
This was taken at art fair yesterday. Here you have the settling down of a giant molecular cloud on a population. Do you have any questions or comments?
Can you repeat that, please?
No, you just got a whiff of the smell of the ham that smokes itself. Although I have to say that this is really the smoke it's quite dazzling. One of my eyes is sort of off kilter because I had on an eyelid I had a very typical small skin cancer. I had to go in to see the surgeon, or that she did was very successful. I had to go in to the Kellogg Eye Center yesterday. Ever been to the Kellogg Eye Center?
Yes.
The home of Special K. And I was in there, and they had their air conditioning going, and the building smelled like an ashtray.
Wow.
I mean, they were seriously considering telling everybody to go home.
Mhm.
So that's pretty awesome.
It was 400 this morning. The scale only goes to 500.
Yeah, yesterday morning, I think Detroit was the worst place. Now, I was in California when they had the wildfires. I was visiting my daughter, who at that point was practicing law in Oakland. And we were 6 blocks from the Berkeley Hills, and we could not see the Berkeley Hills. And the air quality index was about 150. But it was what, 400 or something like that. Yes, and this is
500 in Toledo today.
500 in Toledo.
That's as high as it goes.
Yeah. I mean, perhaps the good side of it is that maybe it will make housing more affordable in this city. But I don't think so. I don't think so, but I'd hate to be somebody who was looking for a house day. But these poor people I drove here this evening, I went past Art Fair, and there were still lots of people there. It shows you the gravitational attraction of art on a stick, of metal rich art, as opposed to metal rich stores. Anything else?
Heard there were places in the central UP where people actually had ash on their cars.
No.
Seriously.
Yeah.
So it's actually ash falling.
They woke up in the morning,
Yeah.
their windshields were all ashy and they had to scrape their windshields.
Great. Yeah.
What's a deep?
Fascinating story, putting it all together. Thank you.
Thank you.
Well, I will.
Kurt's got a question.
I was just wondering, you know the story of, I believe it's SS 433?
I didn't hear you.
You know the story of SS 433?
I don't know it at all well.
Yeah.
Go ahead.
I found the book, the story of it a while ago, and it was one of these things where multiple groups were trying to figure out what the hell do these spectra mean? Because every time they would look at it, it would be different. And it took a lot of head scratching before people finally realized one of the first sort of stellar mass black holes they discovered, and what they were really seeing were signals from the jets coming out. And the whole thing was
Yeah.
precessing and the jets were running. But it's another one of these stories of an observation and nobody knows how to explain it.
Something similar happened with, I may have given a talk to you sometime 25 years ago. That after 1920, astronomers found the mathematics of relativity just too challenging. Heber Curtis gave a course at Michigan about relativity, which he didn't believe, but he said he thought the students should know it. And so people working in relativistic astronomy just weren't any between about 1932 and 1963, when the first quasar was discovered, and Martin Schmidt had gotten a spectrum of that first quasar, whatever it was, 3C273 or something like that. And he was looking at the spectrum and it made absolutely no sense. And he was wandering up and down the offices of the Palomar Observatory. What the heck is going on here? And then all of a sudden, he has this recognition that what he's seeing are the typical lines of the Balmer series of hydrogen redshifted, across the state line. And that immediately caused, among other things, the first Texas something
Conference.
on relativistic astrophysics, which occurred in 1963, and then all of a sudden relativity got popular again. But it was one of these things where I was like, what does this mean to you? And I don't know. I don't know, you know.
I've got a copy of the proceedings, if not from that conference, then from once, I don't know. I think my father stumbled across it somewhere and gave it to me for Christmas.
There's, you know, sometimes these things, when Heber Curtis came to Michigan from 1930 to 1942, he took his turn observing and taking spectrograms with the 37-inch telescope here. And the people who were working with him, Dean McLaughlin, first look at the spectrograms stuff. And he just couldn't understand what was going on, because all of a sudden you'd have stationary carbon lines in these spectra. And he thought, wow, this is really interesting. Maybe we have interstellar carbon, which is stable, doesn't show any velocity, and we're seeing the spectrum of the star through it. So we have proof of the existence not only of interstellar calcium, but of interstellar carbon. Well, McLaughlin went to observe one night with Heber Curtis, and they were standing at the spectrograph. And, you know, it's going to be a 20-minute, 30-minute session. And Curtis takes out his pipe, takes out a cigarette, strikes the match, lights the cigarette.
There's your carbon.
And they found, McLaughlin went to measure the next day, he found carbon and sulfur. So much for that discovery.
It works way off in the distance and it works right up
Yeah.
close to. Yeah. The
The
absorption happens wherever it is.
exactly.
Well,
It's kind of like the stern garlic. Garlic like to smoke cigars. And when he observed that spin up and spin down, the only reason they saw it on the photographic plate was the cigar smoke contaminated it and actually showed a picture that was never shown if he hadn't lit his cigar.
I like that. I like that.
All right.
Well, I will tell you that I thank you for your kind attention. On this basis, so I gave a talk on my birthday in 2015, 2017,
15. Yeah, you were at 15.
15.
Yeah.
So the chance that I will not be gaga in 11 years from now, the odds of that are very, very small, which means that then I'll be able to give you another lecture on flying saucers.
All right. There's a lot of stuff.
I'm going to ask a great favor of you, which is that my family would like to celebrate a bit with me while I'm awake. So I'd like to ask your permission that I may depart.
Please.
Yeah.
Oh, absolutely.
But not before, as a little token of our appreciation and say happy
Oh.
birthday, we would like to give you an observer's guide or handbook.
Oh, thank you.
And could you use a calendar?
I could.
It's a lovely calendar.
That's fine.
They're really nice.
You mean you're
Yes,
not giving it
observers
a
have it.
cigar?
Yeah, I was actually going to order one and I forgot. Thank you very much. Thank you very much.
Thank you, Rudy. Always a pleasure. Thank you very much.
Hopefully you'll have some nice time with your family.
Yeah.
I should. I hope so.
Is your award?
Yes, thank you.
Yes.
But I have to be nice to them because they will decide what nursing home I can end up in.
Well, and whether you get that C star.
It's not us, Rudy, it's gravity and entropy. Gravity is gravity.
Yes, yes. At least what I call the conditions of maturity. Thank you. I hope to see you all on one of today's. All right. Yes.
Oh, and I'll be with you on that October date.
Yes.
Okay. Let's see, I just got a couple of things. I sent out an email earlier about a successful Michigan Math and Science Scholars event earlier this week, which was Tuesday night. And also reminding we have another one coming up potentially next Tuesday with a rain date of Thursday. I know yesterday it looked like the forecast was saying rain on Tuesday, but now they've changed that. And Tuesday maybe it looks like it might be the better date, but we'll see. It's too early to tell. So, but again, we always need help for that. So, and just a reminder that next month we are going to be meeting at the home of Brian Autumn for our club picnic. So we'll be sending some information about that out.
What day is that? That's August.
So Friday, 21, August 21 would be the normal date. Are we doing it that day?
Yeah. Got the regular meeting time.
Okay, Friday, the 21st.
Potluck kind of thing.
Okay.
We'll probably have some kind of a sign up thing so people know what's being brought, that kind of thing. So,
Look for an email.
yeah, exactly.
Yeah, August 21st.
Yeah.
I have a question, Charlie.
Yes.
The smoke isn't supposed to be around next week, but, you know, my limit if I'm running the show is 100. Because that's when some people can really hurt themselves when it gets above
Right.
100. Is there any discussion with the science scholar people as to how to handle smoke? Because I simply wouldn't show up.
No, but we need to bring that up because that is something to think about. Yeah.
I don't think it's been talked about yet.
Yeah. Yeah.
I'll talk to Monica about it. I also hadn't really thought about it.
It's got awful hot.
Oh, I know. Even when we left, we were sweating.
Yeah.
That was like around midnight. Check.
I know, I'm just saying that there's a, you look at the weather on the smoke and that, and it comes, and you see how it changes from day to day, or every 2 to 3 days it changes. So it could be a good day or it could be a bad day either way. We'd have to maybe contact Shannon Murphy.
She's on what? Shannon?
She?
Yeah.
Shannon, you said
Ask
what?
her.
Can you actually hear me?
Yeah.
Yeah.
Okay, good. I'll talk to Monica about it. I'll email her probably this weekend to mention it, because you're right. I don't think this is something that has ever come up before for Michigan Math and Science Scholars. So, but I'm inclined to agree that I don't want to be out there if it's super smoky. So,
Yeah. Messes up his observation too. Done. Okay.
yeah.
Thank you.
Yep. Okay. That is all I have.
Here's what
So,
Cindy,
you got anything down? No?
Thursday morning,
Okay.
the pink and sky.
Check.
We have now 2 calendars or 5 calendars and 2 handbooks left. I talked with Barry on Wednesday night and Tim. Basically, they're kind of at a standstill on some issues on the website. So there's really not much change.
Are there problems that they're dealing with or just everything else?
Part of his, Barry's thing. He was actually on vacation for a week and a half.
Okay.
So it's just a matter of getting, re-engaged with the thing.
All right. No problem.
Settling a few things.
They're busy.
I have a question for you, Jeff.
Yeah.
We have this fantastic email service that runs the club. And I know you're an administrator for that and we're looking to retire. Do we need to be looking at moving our email service from the university?
We are.
The list serve. The listserv.
Basically, we're using listserv that's through the university. It's,
Are you still retiring in October?
I'm still planning on it. The details are, they're a little sketchy because the ITS hasn't really announced what they need financially. I'm waiting for them to announce some packages if they haven't. But Barry's looking into an email server. He says he's set him up for his other clients. It should be no problem. If we do that, then, you know, we can tie in any number of list managers. It's very easy to export the list from Michigan. So, you know, when it gets closer to that time, we can, and there's always a possibility of extending it. Arranging something with the university as an alumni, as a, you know, staff or a retiree or whatever, that we could retain permissions like that.
So, you know,
And Kurt's been
I'm
on
one of
that
the
list forever.
co-owners of the list, and I retired. 11
Yeah, I
years
know.
ago.
I was gonna ask you how that worked out.
And
Nobody said anything.
The directory down.
yeah,
Yeah,
Yeah.
yeah.
And community.
And
I made them up too. I was only an alumni.
And
I was never staff.
still make changes to it, and, you know, we have the authority to add elements to the list and so on, and give other
Yeah,
people with UNM IDs.
I wasn't sure what your situation is, and I basically assumed that they were gonna yank everything because I'm a relatively new employee, but
Well,
with the current.
I put in 40 years at the U. I don't know if that's, I'm also an alum, so,
Yeah.
but,
Yeah, it's
so I
similar
think
story.
basically, as long as you've got a unique name,
Then stick by it.
and.
The real question is, will they continue to host it for outside
The,
groups or not? Maybe they
the
will.
hosting is pretty trivial.
It's trivial, I mean.
But they still have to keep the server running.
Right now, they have to keep it running because it's used for authorization and permissions on hundreds of applications, and for them to move to Microsoft or an Oracle service or some other directory service would be a monumental task.
Yeah,
So-
it's gonna be around for a while,
Okay.
quite a while,
So it took them, what, 20 years to get rid of AFS, so,
something like that.
and they're not done yet.
Yeah,
So,
So at this point, we probably don't need to worry about it, but it is something to think about going forward.
it's in the back of our minds, and I think in, you know, posterity is probably a good idea to, you know, work toward moving it, but it's not an urgent situation.
actually, maybe in 5 or 10 years, it'll be a problem.
When I'm not gonna worry about it.
Once Dave and I are both suffering from
Yeah.
Alzheimer's, and you're the only one left who can make changes.
I do have my wife on there. She's UFM and she's retiring, and
Yeah.
we've got a couple of people we could probably trust to do
Yeah.
that too, so. And any new recruits that are UFM employees are welcome.
I mean, I've created new groups in the last 2 years, last year.
I don't think they police it very heavily.
I'll just create
I just worry, my concern is that they're moving a lot of basic services, like identity management and authentication, things like that, that M community is tied into. They're moving those to centralized consolidated services, and I'm concerned that M community is going to be one of those that, oh, we'll just drop this stuff in and we'll be off and running, and in the meantime, any retirees will be. That's my concern, because I've seen it happen with the Okta, with the web services, and with AFS. So it's like, it could happen. And I'm just trying to be conservative. That's all. And proactive, so.
Thank you.
Nothing to report, just looking to have the observatory ready for the Michigan Math and Science Group.
That was easy.
Yep.
You're gonna have to power wash the telescope to get all the smoke off it.
No, we kept the roof closed. We didn't leave it open. Yes, kept it closed.
Events have been reported to the Observer by my wife. I don't have a report other than that.
Any officers in the Zoom audience? I don't think so, but I don't see
Got
them all.
Dave and then Joe and Shannon. Those are the 3 left.
Okay. Does anybody have anything else? Jim?
We were gonna talk about eyepieces.
Oh, yes. Continuance out of it.
Yeah, of course, I didn't come prepared, but hopefully all of you have read the proposal concerning the eyepieces. Basically, it's a couple of, we've been given a pretty elaborate visual photographic telescope rig that is pretty exceptional in a lot of ways, and visually the instrument is quite good. And to take advantage of that, we want to put a set of eyepieces on it that will take advantage of what the telescope can do. It's a F7 107, something like that. Refractor on a AM5 harmonic mount. And
It's a lovely instrument, very high quality.
yeah, and it does everything that you would want an instrument like that to do. The idea that we've come up with is a couple of Delos eyepieces along with a 2.5x power mate to give us a range of magnifications, basically from about 75 to 20 something, which is, telescope could probably take more magnification than that, but the nights that we have that would actually work out for an instrument that size to produce good images are minimal.
You said it's a 105 millimeter
It's 107 millimeter
diameter.
aperture,
Okay.
F7.
Refractor.
Yeah. Well, 200. You get above that, you're not going to gain anything.
Yeah, no, I've got a 105 650, and in the 20 odd years that I've owned it, I think I've taken it to 300 or more a double handful of times.
Yeah. No, once you get above 40, you're not seeing any more detail. And in fact, but I've done the same with a lot of scopes. This would be 40 years ago or something. We took the 24-inch up to over 2,000 for grins, and it didn't really gain anything. It just lets it do it and see what happens.
But this one, we had some eyepieces that pushed it up to a little bit over 200. I think it was like 215, 220.
Yeah.
And it worked, and it was okay. But
Yeah,
that was,
yeah.
it's an exceptional night, and it was
Right.
one that we could, and a really good target. And
Well, and it's a 4-inch, so
yeah, and so it worked out well. But so we could, but the range that came up with are eyepieces that are really good for
They have long iris.
and
Yeah.
there's a whole bunch of really good qualities to those eyepieces, not just the fact
Right.
that they're.
but for a 4-inch, you
and
don't
it's a
need
nice
to-
range.
Yeah.
We don't need anything more than that, and that gives us a lot of nice things. And they're parfocal, so you can go through and move them around, changing magnification without losing the focus, basically. And so
Until I look through it.
everything that he had on that list really made a lot of sense. And there was quite a bit of discussion with both the officers and the members about that. And I think the proposal, I don't have it. I forgot to
I
bring
forgot
it.
to bring it too, and I'm the one that wrote it, so.
But
No, 200 is
it's a
fine.
nice, right, it's a nice number.
Yeah.
So would it be okay if I made a motion that we want to proceed with this?
I move that you make. a
Well, I'm
motion.
asking Jim first if he's,
Yeah, but the one thing that has been mentioned is the, $1,200 to $1,500 price tag.
yes.
So that,
So it's expensive.
Yeah.
but it matches the scope. The scope was donated to us, and these eyepieces are a match to that type of a scope. Okay, this is not a cheap scope. This is a really high quality
Yeah,
instrument,
it's an excellent instrument.
and it's pretty expensive. The scope itself. So,
We don't have eyepieces from other scopes that will fit it.
well, what happens is all of the other eyepieces, well, they would fit it. But with each one of our loaner scopes, we have a small set of eyepieces to go with them. This came with no eyepieces.
Right.
So we need to
a set,
provide,
right.
we've got the scope, the mount, the motor drive. Tim's gotten the auto guiding working, the plate solving, all of that. So you can actually use it as a go-to scope, and it really works very well. But there are no eyepieces used. So we really need to buy the eyepieces to match that scope.
Does that
Most of
be
the
a loaner, or is
eyepieces
it
we
just
could
gonna
have,
be-
like in the observatory, aren't the kind of quality if that scope
It's-
deserves.
It is available for loan as some of the other scopes are. We have several that are fairly high quality devices, high quality instruments. But that's on special, we have to know who's getting it, right, and using it. Yes, sir.
Any proposal, motion, I think should also include who and how it's going to be acquired. A lot of money to put on somebody's.
Agreed, and we had it written up. So do we table this for next meeting then? Or
Well,
because we had that, we had it all kind of worked out, how it would go about doing this. And right now, Tim is managing the scope and is stewarding it. So they would be stored with the scope, the eyepieces. It would have to be Scoville that would be making the purchase, I think, right? Because he would have the.
yeah,
And we'd have to authorize that. But I don't remember the exact amount, sadly.
$1,264.
You found the email.
All
That's
right.
awesome.
Well, I found the email that says option 2, $1,264 with a 2.5x.
I think that was a mistake. I think it's more than.
Oh, you do? Okay. Maybe we
Well,
should review
well,
it and get
the
the numbers.
original number was 1138.
Oh, that's the revised number?
64, yeah.
Okay,
So 1264 is probably the correct.
That sounds about right.
Yes, Don,
That's-
anything else?
Yeah, I think,
Doug Scoble as of
All right.
June 23rd.
yeah, no, you got it right.
it would be useful to have those during the observing season as soon as
Yeah.
possible.
Correct. So we shouldn't table it. We should probably
Yeah.
proceed with this since we,
Exactly.
so what was the amount, Kurt, again?
1264.
I think you were about to make a motion, weren't you?
And wait a minute, what were the eyepieces?
Well, this is the problem is I found.
The dollar amount, but not the eyepieces? Okay.
Yeah,
So was it 3 Delos or 2 Delos?
No, there's two eyepieces and a Barlow.
Yeah.
So 2 Delos eyepieces, one 2.5 power power mate Barlow. That gives us a range from 75 to 200 power on the Watson scope. And the cost would be $1,264.
Plus shipping, right?
Probably shipping and
Plus
taxes.
Can we
taxes.
just say in any motion that, we're, going market price for those items?
We can try,
Price.
but yeah, this is what we had,
This is what we know now.
right? And then when we go to buy it, so, but we
Nice
need,
email.
okay, it's a
Thank you.
17.3 millimeter Delos. And the 10 millimeter.
Yep. So since we don't have a lot of members here, but we can take a vote.
Yeah.
I'm making a motion that we proceed with this, the proposal, we proceed with this purchase.
Second.
And who's seconding it? Kurt?
By the way, would there be any help in just sending out, if any members out there, and you've got a bunch of members out there, would have a eyepieces that was fit, that would like to donate?
I don't think that would be,
I
but this type of eyepiece, I don't know,
It's pretty.
you have teleview eyepieces laying around you'd like to give away? I think you'd have a long line.
If you do, I got a full.
So anyway, we have the motion, I've made the motion, Kurt seconded it.
Support.
I just one addition that
discussion.
We have this, yeah, how many people we got here and how many people are in the club?
Well, but our rule says who's ever at the meeting will votes on it to authorize it. You don't need
Yeah,
a quorum.
this
to
is
do-
not an untypical attendance, really.
I know, this is just also a general comment that, yeah.
But that's the way it works. How many meetings have you seen where we actually get a quorum?
There's been a
Well,
fair
it
bit
is
of
quorum,
email.
really.
Well, how could you have a quorum in this room when you have over 200 members?
Yeah,
So anyway,
So I would just say, I think you ought to go and just see if there's anybody.
well, we still
It's
have.
kind of a negative vote, but just,
Actually, one.
yeah, just send it out and say, this is what we're gonna do. If you know, do you agree or
So we have
disagree?
Dan
And
Snyder.
chances are you'll get about 4 or 5
The reason
emails
I
back.
Don't go on and disagree with it, is that this has been on the agenda for
Yeah.
some time.
Yeah, couple
And
months,
that is
more than a few months.
what laws require, is that we give this a month or two. Give any of these proposals to spend significant amounts of money, enough time to cook among the members, because these, this proposal went out to everyone.
right.
A lot of email discussion a month ago about this.
Yeah.
I saw no
June
negative
21.
comments from anyone.
Exactly.
Yeah,
Otherwise,
otherwise.
this is a lot of money that
Yeah,
considering the
I
amount. Yeah,
So are we ready for a vote?
I am, that's for
Okay.
sure.
all in favor?
Right?
Is
All
anybody
opposed?
You can't even do anything.
We have enough pain.
One abstain. And then do we have any negatives from the,
Conflict of interest?
do we have any negatives from the Zoom audience?
Yeah,
Anybody in the Zoom
I know,
audience?
will Dave agree to it?
Yeah, I'm fine with it.
Have shown a positive vote. All right.
Would it be of any interest to us for
16.
donations maybe
I kind of for to look.
to these eyepieces? If we wanted to, I'd be willing to throw in a few bucks.
Our treasury has.
The treasury has.
Our treasury is sufficient to cover us.
Yeah.
Yeah.
There's enough in the treasury.
Yeah, yeah.
More than enough to cover.
Okay.
Good idea.
We could even buy Rudi a sea star.
Oh, yeah, that's what we should have done, yeah.
That's a bad precedent.
I think Rudy has a Unistellar, actually. If I'm not mistaken.
Well, you said, well, actually, I'll those keep them. Never mind.
Yeah.
I'll volunteer that once the eyepieces come in, I'll take the scope of the eyepieces and, test them for 2 to 3 years.
I'm gonna have to arm wrestle Tim Miller.
Well, I'll chop that and I'll do it for 20 years.
So what we've been doing with this scope lately is it has been coming to open houses and Tim has been using either borrowed eyepieces from other members or things he's provided.
Yeah.
And the eyepieces he have aren't high enough quality for the instrument. But, if you can talk Jim into loaning you a TeleView then, or what's another brand you like that?
Yeah.
And
We would probably only give it
Explore
to someone
Scientific,
who
that
would
one.
bring it out to use at open.
yeah, the whole point
I
is
would use it all the time.
I know. The whole point though is we're using it for outreach. And that's really where it's being, it's shown a lot of promise and a lot of both good feedback from the public. Views we get through that are exceptional. It's such a beautiful.
The only thing I'm wondering is if we want to actually have something we could run lower power than 70.
But he's got some eyepieces that'll do that.
Well, that's true too. Yeah.
Yeah, and they're not as high a quality, but
Yeah.
but you really need the high quality when you push the
Yeah,
magnification.
that's true too. Counts more, yeah. Yeah.
So this really
All right.
made a lot of sense, and there's been enough discussion. So
Yeah, cool.
Well, and
So
the
pass.
observing season
Like
is
this.
upon us.
Right. Right. We don't have,
Exactly.
ain't got much of it left.
Just saying.
Yeah.
Do we
After the
need to
4th
get
of
an
July.
eyepiece case to hold?
I don't know.
I have a case that'll hold the,
That can come out
motor.
of petty cash if necessary.
Sure, yeah, worry about that later.
Actually, Arthur Craig. $27.
And the officers can authorize that.
Right.
Yeah.
We can't authorize the 1,200, like $1,300 for that.
Well, we could if we all wanted to not be officers anymore.
That's one way to retire.
You think?
How do you get out of here?
Is that a motion to adjourn?
Normally
it's support,
but
Is anybody opposed?
To go.
Who made the motion?
Wait a minute, you voted twice.
Who made the motion?
Oh, yeah,
Joe. Thank you.
so did I, so did I.
Yeah, and Kurt seconded twice.
Yeah.
Does that
All right, thank you, everybody.